All right. So, we have in the 1780s what going on historically, chemically?
Charles Law.
What?
Dalton.
Dalton. We've got what we call the boom in quantitative chemistry. We've got the quantitative chemistry boom. Do you remember rich white guys conducting experiments in their basements?
What'd you call it?
It's the boom in quantitative chemistry. And out of this we get things like Dalton's atomic theory, we get law of definite proportions, all that stuff. Well, Charles at that point is looking at volume of gases and temperature. He finds this weird little, that's okay. He finds this weird proportionality that when he takes a gas and starts changing the temperature, for every 1 degree Celsius change, it changes 1/273rd in volume. This guy had way too much time on his hands. He's measuring things way too carefully. Well, what's interesting, that kind of gets forgotten, but what's interesting is we later come up with the concept of absolute zero, which just happens to be 273 degrees. Absolute zero is negative 273 Celsius. So there are some real significant things about absolute zero. I'm going to make you read that section in your book. But what's nice about the Kelvin scale is when we look at Kelvin, it's directly proportional to gas volume. It is a direct proportion. Change it 1 degree Kelvin, you change the gas volume by the same fraction. So Charles' law connects those two things, and it's just V over T. You've done these problems probably in physical science, definitely in math. We do the same thing with this one that we did with Boyle's. We take a V1 over T1 equals V2 over T2. So let's look at some problems together.